Selected problems from our review package, and just to go over a couple of things so that way we're better prepared for our test this week. So if you're lost, this might be a good place to hang out, or if you just need some extra exposure to these things, you can take a look here too. So the first thing we really need to do with part A of question 1 is we need to deal with this pesky exponent on the outside of the brackets. There's nothing we can do inside of the brackets. It's as simplified as it can be. So here we have to remember that this 2 has to go on every single term on the inside. So here I'll write out negative 3, x to the 4, y minus 3. But now I'm going to have something like 3 squared, which is just 9. And whenever I have an exponent to an exponent, so a power to a power rule, I actually multiply the exponent. So here, negative 2 times 2 will give me a total of negative 4. And this has an imaginary 1 here on the y, so 1 times 2 will give us y to the 2. Now we can go ahead and actually multiply these two things, because when two brackets are next to each other, that implies multiplication. So negative 3 times 9 will give me negative 27. X to the 4 times x to the negative 4. Now remember, when we multiply with the same base, we actually add the exponent. So 4 plus a negative 4 here. So when we add 4 and negative 4, we get 0. And then with the y's, it'll be negative 3 minus 2, which will give me a negative 1. We can clean this up a little bit more, because we know that x to the 0, any number that's other than 0 to the power of 0 will give me 1. So I'll have negative 27. This disappears because it's just multiplying it by 1, and we'll have y to the negative 1. We can take it one step further by cleaning up this negative exponent. So to get rid of a negative exponent, we take the reciprocal of just the term that it's on. So here we'll have negative 27 all over y, and that is our final answer for part A. Part D is a little bit of a different method here, looking at things that are being divided with the same terms. So first things first is I know that 8 and 32, I can write that in its simplest terms as 1 over 4. Okay, so 8 goes into 32 4 times, so that's how we'd write that. Now if I look at the c's, I have c to the 2 on top and c to the 5 on the bottom. So I would actually say c to the 2 minus 5. That's a rule for division. So 2 minus 5 gives me a negative 3. And then d to the 5, and then d to the 4 on the bottom. So 5 minus 4 will just give me d to the 1. And I'm not going to write that 1 there. It's implied just without having anything up top. And then e to the 3. So what we notice here is that we have that negative exponent again, much like we did over on part A. So we can actually take just this term and bring it down into the denominator. So now I'm going to, this 1 still exists, but I'm not going to write it anymore. So we'll have d on top, and we'll have e to the 3 all over 4 to c to the 3. So really that move was just taking that negative 3 and bringing it down to the denominator, and this would be our final answer for part B, or sorry, D. Alright, so moving on now into question number 2. I'm only going to choose one, but this one kind of reflects all of the little bits that we should be able to figure out for your test. So the first thing you might notice is that this 5 doesn't really look like the rest of these things. So we need 5 as log base of 2. And in order to do that, we can actually just say that, well, log 2 of 2, because remember, log 2 of 2 is just 1 to the exponent of 5, which will actually equate to log 2 to the power of 5 will give me 32. So over here, I'd take log 2 of 32 minus log 2 of 8 plus. Now I can actually simplify this even more by bringing that 3 all the way up to the 2 on an exponent. So remember, a coefficient, if we bring it up to the exponent, that is allowed, that is a legal move when we're using logs. So log 2 of 2 to the 3. And I'll simplify that in a second. So now I got to look at this and I'll say, well, my first 2 bits, I'm seeing a subtract, so I know that I can divide them. So I'm going to go log 32 divided by 8. Because I have the same base of 2 here, that is something I'm allowed to do. And I'm going to add log 2, and 2 to the power of 3 is just 8. So 32 divided by 8 is just 4. So log 2 of 4 plus log 2 of 8. And remember, when we're adding, we actually multiply what's inside of the logs. So here we're going to have log 2 of 4 times 8, which will give me log 2 of 32. So we took something that's a little complex and we boiled it all the way down to a single log. That is something that you're expected to know how to do. And just keep in mind that when you see a subtraction, it's a division operation. And when you see an addition, that is actually a multiplication application. All right. Moving over to this thing. So this is one of the questions that reflects how an IB exam is usually structured. So while we haven't really done any examples like this in class, you have all of the tools to be able to do it. And the show that style of asking this question really gets you to think about what you need to do. So really, we need to take all of this and prove that it actually is equal to negative log A of 4. Okay? So the first thing we really need to do is tidy up some of these things. So if you're overwhelmed with a question like this, just start doing some stuff that you know how to do. So here I know that this 2/3 can come up on the 8, and your teachers will know that you are working hard and able to show off a couple of skills here. So log 8 to the power of 2/3. This one right here, I can bring that 2 up as an exponent on 16. So this will be log A of 16 to the power of 2, and this will all still equal log A of 4. Alright, so now I have to go one step further and actually process what these exponents look like. So log A of 16 plus log A of... Now remember that the numerator of a fraction exponent tells me what I do to the number itself. So here I'm actually going to square 8, so I'm going to be having 64. And this denominator tells me what I have to do in terms of a root. So here I'm actually going to take the cubed root of 64. And now I have to deal with this log A of 16 squared. In this case here, log A of 16 times 16, so that'll give me 256. So here I'll actually write 256. Right, because that's just 16 squared. So this is equal to log A of 4 still. Alright, so we're getting somewhere here. So log A of 16 plus. Now, you can do this in your calculator by saying 64 to the power of 1/3, or you can take the cube root in your calculator as well. But this really just works out to be 4, right? So log A of 4 and minus log A of 256 is equal to negative log A of 4. Okay, so now we have quite a bit of stuff here on the left-hand side still. It's been simplified though, so now we can take our addition and our subtraction and actually work through all the log rules that we know. So here, log A of, and I'm going to do it all in one bracket here just to show you that this is a possibility. So because the log A is all the same through all of these things, I can actually just take it as 16 times 4 all divided by 256. And that will equal negative log A of 4. Well, 16 times 4 is 64, and 64 over 256, that's just another way of saying 1/4. Now, if you don't believe me, you will have use of a calculator on the test, so don't worry if these numbers freak you out. You will be able to process them on your own, but keep in mind, a skill to have is to work on your number sense always. So here, this is where a lot of students get stuck. So you're wondering, well, how can this look like this? And it has to deal with our exponent background and how well we can deal with exponents. So here, another way to write 1/4 is the same thing as saying 4 to the negative 1. Because remember, if I have a negative exponent, I can take the reciprocal and make it a positive. So here, if I have 4 to the negative 1 is equal to log A of 4. And remember that this exponent can come down in front as a coefficient. So here I'll have negative 1 of log A of 4 is equal to negative log a of 4. And of course that 1 is just imaginary, it's really just a placeholder, so here I actually have negative log a of 4 is equal to negative log a of 4. Now this looks like a lot of confusing work, but if you take it each step by step and you do each little rule that you know how to do for each line, you will eventually get to somewhere around here, and then just remembering that you can bring that 4 up as a number with a negative exponent. And to be completely honest, this is a little bit of a challenging question. You should expect something like this to show up on your test on Friday. So this is another IB style of question that requires you to think a little bit differently. So here I have some representative of log a of 4 as p, and some representative of log a of 6 is equal to q. And what we're asking here is we're expressing the following expressions in terms of p and or q. What all this really means is that we have to look at this number here, so this 24, and how does 24 relate to 4 and 6? Well, we know that 24 has factors of 4 and 6 because 6 times 4 is equal to 24. So if you were to break down 24 and say log a of 6 times 4, and remember that our rules can go both ways, so we can simplify things by putting them in brackets, or we can expand by saying that this is log a of 6 plus log a of 4. Here we already know that we have some representative numbers, or sorry, letters that have log a of 6, so that's q, and log a of 4 is p. So here my answer will be q plus p. It really is simple to do mathematically, but in order to wrap your head around what represents what is a little bit of a challenge. So what we learn in class is some rules, and what we might be tested on are some very flexible ways to use those rules. So just try to remember that when you're preparing for your test. Here I do the same thing. I'm looking at 36. 4 and 9 can go into 36, but I don't have a 9 option here. But I do know that 6 and 6 can go into 36. So here, if I were to break this down as saying log a of 6 times 6, or alternatively, you can get the same answer by expressing this as log a 6 squared. Now you can figure that one out on your own if you'd like. I'm going to show it this way, just like the part A, where we have log a of 6 plus log a of 6. And log a of 6 is equal to q, so if I say q plus q, and adding like terms here, I'm going to have 2q. So this question is really just to get you to use the same rules in a little bit more flexible fashion. If that's a challenge for you, just trying to break it up into really expanding this expression will get you some part marks, and then hopefully you can see that they equal something that is already represented. Okay, so I chose E and F for part 5. The first row, so A, B, and C, were all repeat types of questions from our exponents unit. And if you have any questions about those, you can send me an email, give me a text, or whatever you need in order to get some help with these things. But really, we're going to work with the log section of these two questions. So here, I will divide both sides by 6 because I don't like that pesky coefficient in front. So I'm going to get rid of that, and that'll delete the 6's on the left-hand side, and if I take 36 divided by 6 on the right. So what I'm left with is 3 to the x plus 2 is equal to 6. Now with our exponents unit, we would try to find a way to massage this into the same base. But here I have 3 on one side, 6 on the other, and in all likelihood there's no way I can get the same base with whole numbers that I'm used to. So what we must do is take the log of both sides in order to get that x down away from an exponent. So here if I take the log of 3 to the x plus 2 is equal to log of 6. One thing to remember is take the log of both sides and not just the number side that you're interested in. So here now that this x plus 2 can come all the way down in front. So x plus 2 of log 3 will equal log 6. Okay, so remember that this actually is still a term by itself, right? So this is x plus 2, and it can be treated as a coefficient. So really here we're going to divide both sides by log 3. So that way we can start to isolate x by itself. So here divide both sides by log 3. And now we'll have x plus 2 is equal to log 6 over log 3. And I'll tidy that 3 up. It kind of looks like that's my base, but it is not. And just to remind you guys that when we don't see a base for logs, just remember that it is actually using base 10. So now I need to get x by itself again, so I will just subtract both sides by 2. So I'll say x now is equal to log 6 over log 3, and that positive 2, when I bring it to the other side, will be a negative 2. And you might not be comfortable with leaving this as an answer, but to be completely fair and honest, this is the most exact answer that you can get. So if you put log 6 in your calculator divided by log 3 in your calculator, you're going to end up rounding. So right here, if we leave it as that, you'll get full marks, and you'll be more exact than if you were to use your calculator. Over here on the other side, just to show you that, the same algebra rules apply for a lot of these things. So I need to move this negative 4 to the other side so I can begin to isolate x. So here, 3x is equal to now 15. In this case, it's going to be plus 4 because I moved that 4 to the other side and I have to flip my sign. So here, 3 to the x is equal to 19. And again, taking the log of both sides because I don't have a base that is common between 3 and 19. So here I'll have log 19 on the right. This exponent again can come down, so now I have x log 3 is equal to log 19, and dividing both sides by log 3 will give me my final answer. So I'll cancel on the left. X is equal to log of 19 all over log of 3. Get used to leaving your answers in these log forms because, again, like I said before, it's much more exact than leaving them as decimals that are rounded. So here I'm going to show you how to set up these questions for part 6. I'm not going to go through them though because a lot of it has to do with the old exponent unit that we had. So when you see an expression like this and you'd like to find out what it equals, just remember that it's equal to some x, right? So you can create this out on your own. Now here this is just saying that 4 to the x is equal to 64. You'll notice that these will have some sort of the same base, and you can use 4, and you can use 4 maybe even to the power of 3 if you'd like to use that, and you can keep and continue to use using our old exponent rules. Here the same thing applies where we say 5 to the x is equal to 1. Remember how to convert these things back and forth, so 5 to the x is equal to, oops, sorry, that's supposed to be a 1, and just try to figure out what that x would be. And remember that anything to the power of 0 will give us 1 for this question. Now before I would set this up, I would actually move my coefficient up to the exponent for part C. So this would be log 3 of, and 3 squared is 9 is equal to x. That means that 3 to the power of x is equal to 9. And it should be pretty obvious what the answer to this be. But if not, you can take a look at the review solutions that are posted on the portal page. Last but not least, I was a little bit lazy here and I just wrote out the equation, but we're talking about a tank that has 10,000 liters and it's losing its liquid at a rate of 0.933 to the power of t. So the first thing that we need to do is we need to plug in 5 minutes for t to figure out what our answer should be for losing all of that liquid over the first 5 minutes. So here, it's very, very simple enough to just put 10,000 times 0.933 to the power of 5. Now, I don't have my calculator handy on my computer today, so here I'm just going to let you know that the answer for this is 7,069.8 liters. Okay, so that is how much I have lost after the first 5 minutes. B is all about the time of half of the initial amount to flow out. So remember that we had 10,000 to begin. And half of the initial amount will be equal to 5,000. And 10,000 doesn't equal 5,000, but I'll just fix this up here and say that half of 10,000 is equal to 5,000. Right? So here I know that half of my initial amount will be 5,000. So here I actually replace that in for V. So 5,000 is equal to 10,000, which is my initial expression, times 0.933 to the power of t. Here I want to do some tidying up, so I'm going to divide both sides by 10,000 to make this algebra a little bit easier for me. So I'll cross out my 10,000s, and I'll divide this side by 10,000 as well, leaving me with 1/2 is equal to 0.933 t. With our problem solving before, we used to go through the process of of graphing this and trying to find the intersection point, but in reality now we can take the log of both sides, so the log of 1/2 is equal to the log of 0.933 t. And from this point we can bring that t down. So log of 1/2 is equal to t log of 0.933. And to get t by itself, we must divide by log 0.933 on both sides. And when we're doing this, again, I always stress that you can leave things as an expression of log, but for the sake of this question where we want to actually know the amount to flow out, let's go ahead and we can put that into our calculator. So log of 1/2 over log of 0.933 is actually equal to t, and when putting that into our calculator is 9.99 minutes. So here we're at 9.99 minutes, and let's round that to 10 because it's asking how much time it takes for it to lose all of that liquid. Again, we have to round up in this scenario where t takes about 10 minutes. Finally, we're looking at the last bit of of question 7, where we want to know when 95% of the liquid flows out, and we also want to show that it takes almost 3/4 of an hour for this to happen. So 95% of 10,000 is going to be 9,500. Right? And that leaves us, therefore, that leaves us with 500 liters left over. All right, so if I have 500 liters left over here, that's going to be my V value. So 500 is equal to 10,000, 0.933 to the power of t. And it's really the exact same process as the last bit, just getting you to do it again. So your teachers are really trying to make sure that you understand how to use logs in this capacity. So here I will divide both sides, and I can't draw a straight line today for some reason, dividing both sides by 10,000, crossing these out and dividing 500 by 10, 1, 2, 3. And that'll give me 0.05 is equal to 0.933 t. Take the log of both sides again, so log of 0.05 is equal to log of 0.933 to the power of t. And again, I can move that exponent down and then divide both sides by log of 0.933. I'm going to do that all in one step just for the sake of time here. So I'm going to divide this by log of 0.933, and that'll equal t. And here, that t is equal to what would approximately be 43.2 minutes. So you can see now where it takes about 45 minutes for this all to pour out. And that's what the initial question was asking us to show. So here, in doing all of this work, you really showed that it took almost 43 minutes to do this. The last bit of the review requires you to sketch, but we did that. We've already been assessed on that, and if you do have any questions about that, you can let me know. But as far as this review goes, here is where we're going to cut it off. And if you have any questions or concerns, please email one of your teachers or come and see us in person, and we'd be happy to help you. Happy studying.